So I want to discuss the concept of consensus theorem that is quite applicable in digital logic. It's used when you want to solve basic Boolean algebra. It's like an addendum to the many rules that we have learned in Boolean algebra, like the one that says A or A bar is equals to 1, A or 1 is equals to 1, A or 0 is equals to A dot 1 is equals to A dot 0 is equals to 0, and A or A is equals to A. So this theorem now states that if you have three terms, this one, these three terms, and they each has two variables. In this case, term 1 has term variable A and B, term 2 has the variable A bar C, and term 3 has B and C. So if you have that kind of Boolean expression, you see that it can be simplified by looking at the variable that exists in two forms, both complemented and uncomplemented, and dropping or omitting the one that has variables that exist only in uncomplemented form. And for that reason, in this case, B exists only in uncomplemented form and C exists only in complemented form. And for the term of that has those two variables may be omitted. That is what is referred to as the consensus rule. So we say it's a conjunction of all the unique literals of the terms, excluding the literal that appears unnegated in one term and negated in the other. So in this case, we are saying that the variable A is unnegated in one term here, and it's negated in the other one. So these are the variables or the literals that you keep, and the one that has the uncomplemented variables is omitted or dropped. So that's the general introduction to the consensus theorem or the redundancy theorem, and we can prove it as follows. We remember one of the basic Boolean algebras that says that A or A bar is equals to 1, and therefore you say if we multiply this term that we have seen we are dropping with 1, it will not change anything. So if we are going to multiply this term with 1, then it is the same as multiplying it with A or A bar, which when you open this term, you'll have now the new expression of y as AB or A bar C, ABC or A bar BC. So if that be the case, then we can look for the common like terms that we can factor out. And here we could notice that AB is common in these two of them. Therefore, we factor out A, B, we are going to have 1 or C. We know that this is another of the basic Boolean expressions. We say 1 or C, so is equals to 1. So this is equivalent to multiplying AB with a 1. Similarly, AC, A bar C, and these two terms are also have A bar C as a common term. Therefore, if you factor that out, you are left with 1 or B. And again, A1 or B is always equals to 1. So that is equivalent to multiplying A bar C with 1. You are left with AC. Therefore, we say that the final solution of y should be equivalent to AB, the one that you obtain here, or A bar C. And that now proves what we had seen, that y equivalent to AB or A bar C. So we have dropped the term that had BC after we completely introduced the redundant terms A or A bar. So that is the general introduction to the consensus theorem, and we may use an a POS example. POS means product of sums, which means that we have a sum or an OR operation, another OR operation, and another OR operation. They are multiplied with a dot operator. Therefore, that's why they are called product of sums. So having said that, we observe that they are following the same idea that we have said. We have three variables, A, B, and C. A exists in two forms, complemented and uncomplemented, but B and C exist in only one form of uncomplemented form. And therefore, the term that has those uncomplemented variables is maybe dropped or maybe omitted. And therefore, we are saying that F will be expressed as A or B dot A bar or C. That is how we would solve that problem using the consensus theorem. So there are some rules that govern the consensus theorem, and it says that we should have three variables present, and each of the variables is repeated twice. And in this case, we see that the variable A is represented in the complemented form, and thus all the three conditions that we have defined are satisfied. And the conditions are defined as follows. And I think I have mentioned this one in passing, that for us to satisfy the consensus theorem, we should have three variables which are expressed in a Boolean expression. And in this case, we have A, B, and C, and each variable appears twice, and one variable must exist or must be present in complemented form and uncomplemented form. And therefore, when you apply this theorem, you drop the term that has uncomplemented form, and you take those terms that exist or that contains the one variable that appears in complemented and uncomplemented form.